In this video, we will explain in just 3 minutes, step by step, the symptoms and consequences of refrigerant excess in refrigeration and air conditioning equipment. Let's begin by studying the consequences of having a greater quantity of refrigerant than required in a system. Consequence 1. Excess refrigerant within a refrigeration or air conditioning system leads to electrical consumption above the regular consumption value, RLA, of the equipment, which can be easily measured using an amperemetric clamp and a power cable of the equipment. Consequence 2. Refrigerant overload causes a significant increase in suction and discharge pressures in the refrigeration and air conditioning system. To verify this, the use of pressure gauges is required. Consequence 3. Since the low and high pressures are higher, so are the average temperatures on the low side and the condenser side. This can be verified using a thermometer. Consequence 4. First, let's remember that overheating is the increase in temperature in the evaporator compared to the refrigerant's evaporation temperature. Now we can say that refrigerant overload results in insignificant or zero overheating in the evaporator. This can be verified using a probe thermometer to check that the temperature difference between the evaporator's inlet and outlet is practically zero. Consequence 5. When comparing the refrigerant temperature at the compressor outlet with that at the condenser inlet, it is observed that they are equal or very close. This characteristic of refrigerant overload can be measured using a thermometer. Consequence 6. Let's recall that subcooling is the temperature decrease compared to the refrigerant's condensation temperature. When there is a refrigerant overload in equipment, a slight increase in condenser subcooling is recorded. This can be approximately verified by measuring the temperature of the environment outside the condenser with a thermometer and comparing it to the refrigerant temperature at the condenser outlet. These values are almost identical. Finally, we can say that equipment with refrigerant overload has temperatures immediately at the compressor outlet that are not far from normal values, generally below 100 degrees.